Am I gonna get trick-or-treaters?
No, yes, you are.
I feel like
You
it's.
can't cancel Halloween. But you're gonna give like little kids. They just can decorate their masks with their costume.
Do we think people are not?
Okay,
Just be a mummy and have a white
I
mask.
don't feel like they would.
Or a doctor.
so I'm gonna go over just a few more examples here. The practice quiz is already up. If you want to look at it, like later today. So, look at this guy. A good way to start when you're looking at something like this, especially if you see a square root in there, is start thinking about domains right away. What kind of numbers can go in? What kind of numbers can't go in? So, before we start getting precise, someone throw out a number that can't go into that.
2.
2 is correct. Why would 2 not be good?
Because then it would make the bottom 0.
Very good. So 2 is no good.
-2?
-2 is no good. How about like 5? Can 5 go in?
No.
No.
Well, there's a lot that can't go in.
There's a lot that can't go in. Yeah. Try plugging in 5.
17.
You're going to have a negative number under your square root. That's bad. Well, it's not bad. It's just undefined. It's undefined. So, like I was suggesting the other day, I think using a number line is very helpful. So we can clearly see that 2 and -2 are pretty like critical values to look at. Does that make sense to you when I say there?
Yes.
So it has to be.
Those make it 0. So those are sort of those transition points that make this go from positive to negative. This internal expression here. And we can see if we're bigger than 2, then this thing will be negative. That's no good. If you're, say, like -5, -2.1, those would also not be good. But if you think about it, any number between -2 and 2 should be fine. Is everyone okay with that? For example, plug in 1. Is that okay? Yeah. Plug in 1.99. Is that okay? How about 1.9 repeating?
No, because that's 2.
That is still confusing my brain.
You don't think that 1.9 repeating,
No, it's just, it's a little confusing.
if they're not the same, then we can name a number that's in between them. And GL with that. Because you can't.
Yeah.
Because it's an infinite
It's just.
value. Okay, so anyway,
When is it 2? How many 9s do you need for it to be 2?
infinitely many. Yeah.
So.
If you ever stop, yeah, you can
can't
wait
even have
9 trillion 9s, and then it would be less than
We
2.
don't have infinite 9s available to us.
True.
We gotta work with what we got here.
Yeah, if every atom in the universe and turned it into a 9, it still wouldn't even be, it would be less than 1% of the required number of 9s to make it equal to 2.
Yeah. It'd be way less than 1. Wouldn't it? 'Cause you need-
It's well, yeah, you could say it's an infinitely small percent, because no matter what number you come up with, it's still, in a sense, infinitely close to 0 compared to other numbers. Right? So, anyway. There's the domain. In any case,
Okay.
domain.
Is this even or odd?
What do you think?
Even. I don't know.
Well, let's try it out. Here, X, Y. What's an easy number to plug into this?
2.
1. 2 can't go in.
Oh,
yeah,
bummer.
3 can't go in. Are you messing with me? 1's fine. Yeah, it's
Yeah, I'm
1.
messing with myself.
Okay, plug in 1. You get 1 over the square root of 3. No one's confused by that, right?
No.
Plug in -1. Here's where we see this is the thing to look at, the squared. So you'd also get 1 over 3. So which one is it, even or odd? Even.
Even. Steve.
What kind of thing's going to happen at 2? What kind of structure is that when you have a number that makes you have, if I could plug in 2, I'd have 1 over 0. What does that tell us?
Tells us that we can't do
No. Holes come from if you have a number that makes it 0 over 0. That's a lot of times causing a hole.
anything.
It bounces.
You guys are killing me.
It would be an
It's a vertical asymptote.
Are you sure?
right? Right. If x was very close to 2, if x was 1.999999999, then this bottom thing here would be awfully small, wouldn't it?
Yeah.
If x was 1.999. This would be very tiny. You'd have 1 divided by a teensy number, which would create a very big number. So that tells us is that over here at x equals 2, the function's going to blow up, get real big. By the way, what's the y-intercept of this function?
Let me get my note card out.
1/2.
Very good. Does everyone understand that?
Yes.
This- To get the y-intercept, you plug in 0. You plug in 0, that reads
Because it's 1 over 2.
1 over root 4, which is 1.
You just go for
How do you determine like end behavior?
Well, like this, is there any sense in end behavior of like going to infinity? Does x approach infinity?
I know it approaches.
Yeah, if you really wanted, we can say that as x approaches 2, y is approaching infinity. So that's what's happening. It goes like this. And on the left-hand side, as x approaches -2,
Oh, because
Why
there's
approach?
nothing because it has to stay in between that set of numbers.
the domain is just numbers between -2 and 2.
Interesting.
So our graph is constrained between those two values, those two x values. And then, so interestingly, it has this very finite domain. The width of the domain is just 4, but the range is infinitely large. It goes from 1/2 to infinity.
Can we do a problem like
Sure. Yeah. Let's do 14.
14. What's that noise?
So what does this look like? Well, let's get the domain first of all. 5's fine. If you plug in 5, I mean, you're definitely looking at the right thing though. 5 and -5 are certainly
it's not
relevant.
underneath anything, so it can be 0.
Yeah, if you plug in 5, it reads square root of 0. Is square root of 0 okay?
0.
So 5 itself is okay.
You can't have the square root of a negative.
Right, so if x was like, say, 4,
Then it would be a negative.
I'd have a negative. So
it
that
has to
means
be- yeah.
this inside area is no good. But if x is bigger than 5, then this stuff is, the thing under the radical is positive. Same thing on the left. So the domain of this is basically numbers 5 and to the right and -5 and to the left. The way you write that would be x values that are less than or equal to -5 and x values that are greater than or equal to 5. Technically, this is an or.
Oh.
Because it's or because can a number be greater than 5 and less than -5? No, it's not possible.
Possible.
Speaking of which, I've seen people do this before. This is of course, now that I tell you this, if I do it just to make me annoyed, but where people, it's actually hard for me to even like write it because it makes so little sense.
I think I wrote it like this.
Where you go x, how does it even work?
Oh, they do it like in one thing.
You put like a 5 here. You say, okay, so x is greater than or equal to 5, and x is less than or people just do this, I think.
Yeah.
Makes no sense. Do not do that. That is disgusting.
No.
It's wrong on many levels, but the most obvious being 5 is not less than -5. So it's just very wrong. Please don't do that.
Okay.
If in this case I can do it here because Is 2 bigger than -2? Is x between -2 and 2? Yes. This difference here is this is and, this is or. Can a number be bigger than -2 and less than 2? Sure, 1 has that property. So, hope that makes sense. Okay. This next stuff's pretty interesting, I think. Well, first of all, even or odd?
Even.
It's even.
Because there's the square root,
Very.
or the,
This guy's really makes it even.
yeah.
So you
that's what I said.
test out a number if you're not sure. Maybe plug in. We do want to show our reasoning, so take 2 seconds. Plug in 6, you get root 11. Plug in -6, you get the same thing, root 11. So that's good evidence that it's an even function. Again, the squaring kind of negates the negativeness of the number. The squaring makes this function blind to the positiveness, negativeness. Okay, here's the fun part though. For end behavior, would you guys agree with me that for large x values, let's say x is really big,
15.
that 25 is not going to matter, right? If x is a million, 25 is so tiny compared to him, we can kind of ignore it.
It's gonna stay big.
But look, yeah, it's going to get large, but more importantly, you'd have y is roughly equal to the square root of x squared,
Which is the absolute value of x.
which is the absolute value of x. So what that tells me is that this function has the same end behavior as this parent function. Does that make sense, everyone?
Yep.
Now, what does that
Why is
function look
the
like?
absolute value? Oh,
Because if you put a negative in for x,
yeah, we said really big, so it would just be.
Big negative or big positive.
Oh.
So this is a true fact that we definitely want to keep in the back of our heads. The fact that there is, and Colin, yes, 100% correct. If I plug in, say, -5 into that,
Yeah.
you get +5. So this is not an obvious fact. It takes some thought, but if you think about plugging in a positive or a negative, you'll see that that's true. So anyway, what that means is that my function, as we established earlier, if I plug in 5, what do I get?
0.
0. If I plug in -5, what do I get? 0. And I know that as my x values get large, my function looks like this. So the curve is going to get really flat. It's going to get really linear as you go to the right. And the same thing, it's an even function, so I know it does that.
So you wouldn't draw like an asymptote on like -5 and 5, which
No.
is like really.
Don't do an asymptote. An asymptote is created by,
If it can't be,
like,
if it makes the not 0.
what's really causing it, if you want to get precise, is the fact that x values very close to 2 produce very large y values. Now, the way you usually detect that in practice is if I were to plug in 2, I'd have 1 divided by 0.
Oh, but that's what approach is. What approach?
Here, there's nothing I can plug in that's giving me like division by 0.
Yeah.
Nothing there.
Okay.
So in practice, a lot of times you're going, do I have any vertical asymptotes? Well, I find them by saying, are there any numbers that make me be dividing by 0? And of course, the exception to that is like a hole. A hole is that special case where, oh, if it's 0 divided by 0, then you might have a hole there. A funny name for this, hyperbolic behavior. Is that a cool name?
Hyperbole.
Yes, same, I
I don't
mean,
even
close.
know what a hyperbole is.
A hyperbole is being like, is when it's warm, you say, I'm literally burning alive.
Oh, yeah.
An exaggeration. Yeah. A hyperbola or a hyperbola is actually a mathematical structure. This is half. If I made the bottom half, it would be a hyperbola. So you can describe this behavior where it's curving, but it gets more and more linear. You can describe that as hyperbolic behavior. If you want to just flex on them, you know.
Linear. So is there like a point where it's just a line, or is it always almost just a line, sort of?
It will never be exactly linear, but
Get real close.
yeah, there's a really interesting idea that if you take an analysis class you talk about, which is it's sort of this game where you say, you like person A picks this, they pick up the smallest number they can think of, and then person B finds some value at which the function is within that tiny bound of being linear. So it's this idea of
Where is it?
it's like when you talk about like something approaching zero, you go, does it ever actually get to zero? No, but you can play this game where you say, you name the smallest number you can think of and the smallest positive number, and I'll find you a spot on the function that's closer than that to zero. And if you can play that game and always win, then you can say that it truly approaches zero. It's kind of a fascinating idea. They call it the we're actually going to study limits in this class, but we're not going to study them in that super rigorous fashion. But anyway, when we get to that, I'll bring it up again. Okie dokie. Let's do a fun one here. Some of them are just. I mean, I want to do a lit one, obviously. Right, Aslan?
These ones look pretty lit on the left.
Oh, yeah.
Yeah. Let's look at I don't know. We can do.
How about that number 20? That could be.
Want to do 20?
Looks
Okay.
pretty lit.
I would say
7.
It has lots of things.
I think is gonna be an important
Let's do
number.
20.
Which one?
7.
We can bounce around. 7?
No, not number 7.
No, I'm just
Like,
saying.
Oh.
Seven is a number.
No, that's good. That makes me happy that you said that.
Because if you put it in there, that's got something to do with our domain.
Yes, very good. That's a very good thing to identify. So right away, see that 49, you see that x is squared, huge hint that 7, not only 7, but -7 are going to be important values to consider. Right?
Yes.
Now,
Don't make fun of me. It is so mean.
okay. Let's answer this question. Can x be 7? Is it okay for x to be the number 7?
Yeah, no.
It's not okay, because you'd be dividing by 0. The bottom would be 0.
Right.
So 7's no good, -7 is
And
no
if it's
good.
bigger than 7, if it's bigger than 7 and smaller than -7, it's no good.
Very good. Everyone understand that?
Nope.
Okay, let's say x was 8. Can 8 go in there?
No.
No, because you'd be having a negative under the square root. So this area is no good. Same reason. Can x be like -8 or -9? No, I'd have a negative under the square root.
So be that middle stuff.
So then we can write it.
So this is a big hint. Look at this drawing. Isn't that exactly the same shape as, what number was it?
14? 16.
16. Notice the structure. Take a second. Look at 16 and look at 20. They're very similar to each other. Right? Are they?
Yeah.
Well, see, both of them have on bottom like a square root of a number minus x squared.
Right,
So
right.
that, in terms of that, they're very similar. So they have very close domains.
Mhm.
So anyway, domain is -7. It's a 7. Is this function even or odd?
So
I feel like it's even because there's an x squared.
let's give it a whack.
What if there weren't absolute value bars?
I think it would still be even.
No,
Because then
it
it could be
wouldn't.
negative.
So there's two things going on. The fact that x is squared helps make it even,
Right.
helps. But this is really big because let's say we plug in, I'll plug in 5. If I plug in 5, I'd have 5 on top, and the bottom would be the square root of 24. Okay. Plug in -5, well, that absolute value ensures that the top is positive, and there we go. We have the same positive y value.
Wait,
Because if it didn't have the absolute value bars,
Then
there
they
would be a
would be
-5 on top.
Exactly. So if there was no absolute value bars, this would be negative. The way it's written, it is even. From the graph,
Is it just kind of parabola-ish? Kind of.
A little bit. Where does the y-intercept? Plug in 0. What comes out if you plug in 0?
7.
It's 0.
0.
Zero. So it's
Plug in
Are
0.
those things the -7 and the +7?
Yes, this is x equals 7. This is x. Now, why did I make asymptotes?
Is it only for 0 votes? Or when the thing gets really big, it's a curvature? I mean, no sense.
So how do I know to put asymptotes? The simplest answer is if I plug in 7, it would be 7 over 0. That's a big red flag or whatever, big alert. That tells you vertical asymptote. If you want to be very precise, you'd say, well, technically the reason there's a vertical asymptote is because if x was very close to 7, say if x was 6.999, the y values would be very large. But does that make sense?
Yes.
So you can certainly identify the fact that it's a vertical asymptote without getting into the precise details of what a vertical asymptote is. You can just go, oh, 7 divided by 0, I know that creates a vertical asymptote. So the only difference between this one and that other one is that this one comes down and touches the origin. Boop, indeed. Let's
It's all about attitude. Open your mind. We gotta.
If you have a positive attitude about your test, you'll do great. Doesn't matter if you know it or not. You just need to have the right, open your mind.
But if you go at learning the material with the idea that you won't know how to do it, then you won't if you don't try.
Figure it out.
It's true.
There was a famous book, huge bestseller. I think it was called The Secret.
Yeah.
And I believe I didn't read it, but my understanding was the actual thesis was something along the lines of like, if you really focus on your goal, you can achieve it. But what popularized it was people coming up with these stories like, I really wanted a new car, so every day I would just sit there and just think really, really hard about having this new car. And then one day I won a raffle and I got a new car.
Oh my god.
It'd just be like these ridiculous stories.
This was a what?
It was called The Secret, but there was all these like sort of all the hype and buzz around it. A lot of it involved these like crazy stories about like people who just like visualize something they wanted really bad and then it just happened.
I should do that.
Fantastic.
I love to need some visualization.
We had
Let's do another one. How are we doing for time here?
I thought we'll do that one.
Oh, we got to. What is this?
We have 6 minutes.
We only have 6?
Which number?
I was going to go over one more from here, and then we're going to go over the last 5 questions.
Like on the bell.
I might cry. I think
Why?
that I feel like I did good, but deep down inside, I probably didn't.
You're very in touch with your feelings.
I cried.
I'm a little envious.
Is this number 17?
It is.
Yeah, so 17 looks like this. All right, this is going to be a weird one.
This is on.
Very good.
I know
Very
that.
good. Right off the bat.
I am learning.
Okay.
Because there's an X not that
Let's knock this out. Yeah. Let's say you plug in 5. Doesn't matter what you plug in, but say you plug in 5, you'd have 5 over the square root of 21. Plug in -5, you'd have -5 over the square root of 21. Those are opposite numbers. That tells me that it's an odd function. Great.
When will this go to my phone for infinite simplicity? Sorry, is it?
Yeah. It'll take a little while. Don't worry about it, May.
What's happening?
Do this problem with us, May.
You want my other problem set?
Yeah. Yeah, but okay. Let's look at the domain. Domain. This one's a little different. See, it's not 4 minus x squared this time, it's x squared minus 4. So 2 and -2 are the vital values to look at. Yeah. This, again, you can't be 2. 2 doesn't work because you can't divide by 0. You can be bigger than 2, you can be less than -2, but you can't be between 2 and -2.
It could be 3.
3 is fine, yeah. Plug in 3, you get 3 over root 5.
Could also be 4.
Does that make sense? I need to make sure that this radical is positive. The thing under the radical is positive. So x can't be 1, for example, because that would give me -3 under the square root. We can't square root negative numbers. All right, so got the domain. And think about plugging in 2 would cause what type of structure to emerge? If you plugged in 2, you'd have 2 divided by 0. Very good, vertical asymptote at x equals 2.
And
And -2 for the same reason.
And then it's gonna go out.
And then there's one last thing, which is that end behavior is very strange here.
It's,
Because from the end behavior, what do you think, Colin? What's going to be?
well, okay, so if we put, it's gonna be like x over x squared kinda, right? Well, it would just.
X over the square root of x.
Yeah. So it would just be.
X over X. Or X
Kinda.
Right?
As x gets really big, y is going to approach
1.
1. But on the left side,
Negative.
it's going to approach negative. By the way, a big hint on that one is the fact that it's an odd function.
Oh, because that would be approaching different.
Yeah, for an odd function, if I'm approaching 1 on the right side, I have to approach -1 on the left side. Otherwise, I wouldn't be odd. So this also has a horizontal asymptote of y equals 1 and a horizontal asymptote of y equals -1. Wow. Disgusting. Look at that. No, actually, this is very nice. And remember, this middle is my no man's land. Nothing is going to happen between -2 and 2. So my graph just has to look something like this. So he looks like one of those 1 over x functions, kind of, but he has this huge gap in the middle and this band through the middle here, where there's nothing. So very strange domain, very strange range. All right, guys, the last few things here to cover is just going to be, these are just sort of abstract questions on the back. No, these should be pretty straightforward. Like, so given that f, so I'm not going to tell you what the function is, you just know it's some function, it's even, it's an even function, and f of 3 is -8, which statement below has to be true? Yeah, it's choice 3. So for an even function, choice 3. If f of 3 is -8, then f of -3 would also have to be -8.
Yeah,
Everyone?
we did the table.
Yeah, exactly. It's just, make this table, same y value for a pair of opposite x values. 22. Now here is if you were wondering, I know you were all wondering. Excuse me, sir. I need a precise, rigorous definition of an even function. Otherwise, I just, I'm too dissatisfied. Okay? 22 says, given that f is an even function, which statement below is true? Is it true that, yes you do. If f is an even function, is it true that f of x, write this in the word. Is it true that f of x is equal to f of -x for all x?
What is for all X?
For every x value you can come up with. So like on 22, choice I is basically saying something like, is it true that like f of 5 is equal to f of -5?
Yes.
An even function, that would be true, right? Wouldn't it? Plugging in 5 and -5 would be the same. Now these ones with absolute values, these are kind of just red herrings. We don't really care so much about absolute values. We're talking about evenness and oddness. Yeah, what choice I says, where it says f of x is equal to f of the opposite of x for any choice of x.
That's the end.
That's the actual definition of an even function. You could totally actually on me right now. I think you could be like, actually, shouldn't it say for all x in the domain of the function? And I have to be like, yes. Technically, yes, x has to be in the domain. For 23, which one do you think it is? It's 2. F of x is the opposite of f of negative x. You guys can figure out the last two. I'm sure.
Here's this thing.
For 23, it's choice 2.
Me too. This is sick.